Okay, so the last time we talked about, we had y equals, let's say, 2x squared plus 8x plus 2. From there, you should be able to find your a, b, and your c. A was 2, b is 8, c is 2. So once we have that, we can find our vertex using h, the opposite of b over 2a, gives me the opposite of 8 over 2 times 2, negative 8 over 4, it gives me a negative 2. So h is negative 2. Plug that in to find k. Remember to square the negative first. That is always going to give you a positive. So we have 2 times positive 4 minus 16 plus 2. And it gives you a k value of negative 6. So that means our vertex is the order pair of h and k, which is negative 2, negative 6. Then we can graph it. So negative 2, 1, 2, 3, 4, 5, and 6. There's my vertex. Axis of symmetry, a lot of times it's just abbreviated AOS, is going to be x equals whatever this x value is in your vertex. And you can draw it usually in a dotted line. And before we even start filling in our table, we can look at A, and A is positive, so that's going to tell me that our parabola is going to open up. So if we have it open up, we can do a table. Remember, one step off at a time, so if I plug in a negative 1 step off the x-axis, axis of symmetry, that is. Negative 1, so I have 2 times negative 1 squared plus 8 times the negative 1 plus 2. 1, so 2 times 1 minus 8 plus 2. 2 minus 8 plus 2, negative 6 plus 2, and finally negative 4. So negative 1, negative 4. Mirror that. It's going to be a negative 3, negative 4, so I can put that in my table even though we haven't done the work for it. Take one more step off. I'm going to plug in a 0. It's going to be a 2. Again, I can mirror it. So this is going to be my parabola. Okay, so what we're going to do now is we're going to kind of step it up a little bit, and we are going to work on intercepts. So there's different situations with intercepts. We are mainly talking about x-intercepts, and there's another name for those. They are called solutions. They are called zeros. And they might even be called roots. Okay? So what we're looking for is, here's 3 different situations. If I have a parabola that looks like this, wherever it intersects the x-axis, which would be right here and right here, those would be called my intercepts or my roots. And we will find out how to determine those, because they're not always going to be nice, neat numbers. Okay, so our x-intercepts, our roots, or our zeros. You may have this scenario where your parabola just touches. So that would have one x-intercept or one solution. And let's go back up here. This has 2 solutions. And then we have this scenario where our parabola does not touch the x-axis at all. There are no solutions. No solutions, no x-intercepts. Okay, so we are going to start talking about vertex form. So y equals a times the quantity of x minus h squared plus k. There's several things that are going to happen here. You will start to notice that a is going to be things other than 1 and negative 1. So you're going to see what happens when in relation to the parent function that we talked about in part 1. So the a determines opens up if positive. It also determines if it opens down if negative. And what we have not talked about yet is what happens if a is not 1. So if a is the absolute value of a, let me change this. If the absolute value of a is greater than 1, then that means it's going to be narrow. I'm going to put narrower than parent graph. If the absolute value of a is less than 1, that is going to be wider than the parent graph. Okay? The reason why I put absolute value is because you kind of need to ignore, if you will, the negative sign. It's kind of a bad way of explaining it. But if a is a negative half, the absolute value of negative half is a half. So because it's a half, typically we would think, oh, it's half of it, so it's going to be more narrow, but it does the exact opposite. It's going to make it wider. If the absolute value of a is, let's say, negative 4, absolute value of that's going to be a positive 4, it's going to be, the parabola is going to be much narrower than the parent graph. So it's the exact opposite. Okay? So if I have, let me find an example. So if I have y equals 1/2 x minus 2 squared plus 1. A couple things we can do. We can pull out the h and the k, which is my vertex. This is h, but the formula is the opposite of h. So whatever you see here, you're going to do the opposite. So this is a negative 2 you see, so this is going to be a positive 2, and then k is exactly what you see here, of 1. So I'm going to have the order pair of 2, 1 would be my vertex. Okay, so if I'm looking at this, I'm going to zoom in here a little bit. Not that far. Okay, so if it's a half, is it going to be narrower or wider? It is going to be wider than my parent graph. Axis of symmetry, 2, 1 is my vertex. And I'm going to plug in values. I'm much better at plugging in a 1. If I put a 1 in here, I get 1/2 times x minus 1 squared plus 1. Oops, major mistake. Ignore that. X should be a 1. Negative 2 is part of the problem. Sorry. So I have 1/2. This gives me a negative 1 squared plus 1. Negative 1 squared is 1. Half times 1 is a half plus 1, and it gives me 3/2 or 1 1/2, however you want to look at it. So 1 and 1 1/2 would be about right there. Mirror it. And I'm much better at plugging in a 0. Oopsie, sorry. If I plug in a 0, I have 1/2 0 minus 2 squared plus 1. 1/2 of negative 2 squared is going to give me a positive 4 plus 1. 2 plus 1 gives me a 3. So when I plug in a 0, I get a 3. And then I can also mirror it. So there's my parabola. I want to do one more when you are given the graph, but you do not have the equation. You have to write the equation. I'm going to take this right off of one of the homework problems. Okay, so when I have this, I am looking at number 37. Let's see if I can zoom in there a little bit. Okay, so I am going to look at this, and I already know that my A is going to be negative. Okay, A is going to be negative because it's opening down. I already know that my vertex is going to be right there, which is negative 3 and 8. Okay, I know it's going to be opening down because obviously that's my graph. Oopsie. I need to determine if this is going to be following the parent function or if it's going to be wider or more narrow, because that's going to determine if I even have to find my A. So I'm going to do a little trick, and I'm going to turn this upside down. I know that my parent function means that if this is 0, 0, I would go to the right one, up 1. Because I have the order pair of 1, 1. 2 would be 2, 4. My graph kind of stinks. But you can already tell that this is going to be more narrow than my parent function. Because my parent function would actually be out there. Okay, so we already know that we're going to have to find A. So let's turn that thing right side up again. Okay, in order to find A, we know that the vertex HK is negative 3 and 8. I'm going to put this back in vertex form. Let me zoom back out here a minute. I already know my H and I know my K. My H is the opposite of that, which would be 3. I'm just kind of filling in what I have. And my K is going to be 8. I need to find A. So my A is going to be my A. We need to determine an X and a Y. So that's when you're going to look at your graph, and you're going to look really close and figure out, okay, where does my graph intersect at a nice, neat spot? So I'm going to follow this down. It's really hard to see on this graph, but it looks like right there. This is a nice intersection. This would be the point of negative 2 and 6. So I could use that point. I could use the mirror image of that point. It's like I could also use this one down here as well of negative 1 and 0. So wherever your graph goes right at a nice, neat intersection. Okay, like that would not be a good point because we are clearly off the graph. I'm looking at this going, okay, negative 1 and 0 might not be too bad. So I am going to go back over here, and I'm going to plug in my 0 for Y and my negative 1 in for X. This is going to be a positive 3 because my vertex is a negative 3. So I have 0 equals A times 2 squared plus 8. 0 equals A times 4 plus 8. If we are solving for A, we need to subtract 8 on both sides. Get negative 8 equals A times 4. And divide both sides by 4. Therefore, A equals negative 2. So now we're going to go back to our original equation. Since we found all of that, y equals my a, leave my x, my h is a positive 3 squared, and my k is a positive 8. So this is going to be the equation for that graph.